Example number 3 is more of the same in that we're going to do the same things with a cubic graph than we do with a parabola, but there are some interesting things that happen with this graph. So step 1, plug in all of your x-intercepts where y is equal to 0 and where y is equal to 1. Well, we have 2 x-intercepts, and we have one place where y is equal to 1. Careful with the grid here, that each grid mark is not 1. No problem. We don't really have any nice points that we can add to this. So if we go right away to step 3, where you say, whenever your graph is above y equals 1, your new graph will be below. So here, my graph is below the red graph. And it said whenever the graph is between 0 and 1, the blue graph, or your new graph, your square root graph, is going to be above. So this part here is going to be easy to show that that is going to be above. But we also have this little section to the left. This little section, the y values are also between 0 and 1 for my red graph. So my blue graph also has to be above in this section. And I'll draw it like this. And now I'm going to draw it in purple, but make a tiny mistake. I'm going to also draw it above and draw it there. What's wrong with the purple part? It's above, just like the blue part was. It's between 0 and 1. It's a little bit exaggerated. How far could I go before they would say that's too exaggerated? What value can't I go past? That's the question. Like, if I had done this, you would have obviously, oh, yeah, that looks exaggerated. That looks like over the top. That would be easy to tell that that was too much. But this one is just a little bit exaggerated, whereas this one, that would be okay.
Is it because it crosses with the other point on the graph?
Okay, it crosses 1, right? That's your value, because if it's between 0 and 1 is when it's above. And if you went in this purple graph, which I'll erase, there's a lot of purple happening there. In this purple graph right here, it just slightly goes above 1, and that would be considered too high. I mean, if you went to your calculator and actually, take away the rest of the purple, actually did the square root of 0.125, you get 0.35. So where this blue graph actually should be, I could take that point and go to 0.35, which would be about there. That's more accurate. But if you don't have your calculator and just estimating, anything between 0 and 1 and above would be considered fine. And again, why does the graph not exist to the left of -1? Well, that's where our original graph is negative, and so you wouldn't have that in a square root. Can anybody tell me the equation of the red graph? Because then, I mean, then the blue graph will just be the square root of whatever we can figure out that equation is. The hint is chapter 1. The second hint is it'll be easier if you tell me in factored form. than if you told me in expanded form. Can you tell me one of the factors? We've got an x-intercept at -1, so one of the factors will be x plus 1. We have another intercept at 0, so that means another factor will be x. What happens at the graph at 0? It bounces. So what does that mean for this x? It's going to have to be x squared. Now there might be a number in front, but if I plug in, for example, do you see that we have the point 1 comma 2? If I plug in 1 into this equation the way that we have it right now, we get 1 comma 2. So this is the equation of that red graph. And so what we drew in blue is this equation, which is pretty cool. So you could be asked, just graph, and here's the blue equation, go for it. So what would you have to do? First you would graph the red one, and then you would use the red graph to help you graph the blue graph. What's our domain and range of our blue graph? Well, the domain, x is bigger or equal to -1, and our range, y is bigger than or equal to 0. Questions 10 and 12 for practice.